All right, guys, what happens to pyruvate when it goes to ethanol? Well, what we get is a decarboxylation, so we remove CO2, and then we get a reduction to ethanol. This is what fermentation is. It's anaerobic conversion of glucose to ethanol and CO2. This is like the oldest chemical reaction we've been doing on purpose that humanity has. Um, the carbon source determines the type of alcohol, and then once you hit about 12% alcohol, that starts killing the yeast. Once the yeast start to die, you're done with fermentation. It's also used to make cheese and yogurt. Moving on. Here we go. Okay. ATP and glucose. All right. This is going to be our addition right here. Glycolysis, you get 2 ATP. You make 2 NADH, which equals 5 ATP. If you remember, 1 NADH gives us 2.5 ATP. Oxidation of pyruvate forms 2 NADH. That gives us another 5 ATP. 2 acetyl-CoAs, that's 2 ATP. You get all this stuff. We get 18 here. Total 32 ATP from one glucose molecule. Glucose is our main source of energy. Um, it's the only source of energy for our brain. And then insulin and glucagon we'll get to in a minute. So here, uh, when demands are low, glucose is stored in the liver as glycogen. All right, so it's kind of like a fatty molecule. Glycogen is a polymer, like a fat of glucose, and it hydrolyzes into glucose. So as we need it, we start snipping off glucose molecules in order to generate energy. Insulin stimulates the passage of glucose into the cell. That's what it does. It's not um, what you'd like is you want high sensitivity. So you only need a little bit of glucose, and your cells will start sucking up, or a little bit of insulin, and your cells will start sucking up glucose. And then glucagon, this is a hormone that stimulates the conversion of glycogen to glucose. All right. And this is going to get pumped out as you're like in a fasted state and you start to do cardio. You're going to need that energy. You can start to pull glucose from your glycogen stores. All right. So here, what we get is one glucose compound gives us 32 ATP. Now, gluconeogenesis, this is a little bit different. Um, this is where we make glucose from non-carbohydrates, so from like lactate, amino acids, or glycerols. It happens in the liver like everything. Glucose and glycogen stores are depleted, so we don't have any glucose or glycogen in the system. This like occurs after fasting or sustained activity. What we're doing is gluconeogenesis. We are actually making glucose from other stuff. And this is anabolic. That means we're growing molecules. Um, and so two pyruvates will make one glucose. It's sort of like the reverse of glycolysis. We have pyruvate, all right? We have lactate, it's oxidized pyruvate. Pyruvate is then undergoes gluconeogenesis in the liver because that's where so many chemical reactions happen, and we get glucose.